There is something buried beneath the moon that should not be there. It sits under the largest impact crater in our solar system, a mass so dense that the moon's own gravity gives it away. In 2019, China landed a spacecraft directly above it, uncovering secrets that do not align with any existing models of the moon's interior. To understand what they found, we must look at the far side of the moon. While often called the dark side, this term refers to mystery rather than a lack of light. Because the moon is tidally locked, this face is always turned away from Earth, creating a wall of 2,000 kilometers of solid rock that blocks all radio signals. For decades, this made communication impossible and kept the far side unexplored. The solution arrived in 2018 when China launched Queqiao, a name meaning magpie bridge. Inspired by a folk tale of lovers separated by the Milky Way, this satellite was designed to bridge the gap between Earth and the lunar far side. Instead of orbiting the moon, it sits 65,000 kilometers beyond it, at a special balance point called L2. From this vantage point, the satellite can see both our home planet and the hidden face of the moon at the same time. This achievement marked the first time humanity established a permanent link to this silent world, paving the way for a historic descent. 7 months after the bridge was built, Chang'e 4 began its lonely descent into the abyss. The target was the von Karman crater, a deep scar tucked inside the South Pole-Aitken Basin. This basin is not just a crater. It is the largest confirmed impact structure in our entire solar system, stretching 2,500 kilometers wide. It spans a distance comparable to the journey from Texas to Washington, D.C. It is so vast that even from orbit, its true scale remains impossible to capture in a single glance. 4 billion years ago, a massive object the size of a small planet slammed into the moon, excavating material from depths as great as 200 kilometers below the surface. This violent collision likely exposed the moon's mantle, providing a natural laboratory to study the heart of our celestial neighbor. But there is something else lurking there. In 2019, researchers at Baylor University analyzed gravity data from NASA and found an anomaly so massive it weighs the basin floor down by more than half a mile. Imagine taking a pile of metal 5 times larger than the big island of Hawaii and burying it deep underground. That is the sheer scale of the unexpected mass detected beneath the lunar dust. Scientists believe this could be the iron-nickel core of the very asteroid that created the basin, still embedded in the mantle after billions of years. Alternatively, it may be a concentration of dense oxides formed as the moon's ancient magma ocean solidified. Whatever it is, this strange mystery is exactly where China chose to make its stand. On January 3, 2019, the world held its breath as Chang'e 4 began its final approach. Dropping from an altitude of 15 kilometers, the spacecraft fired its rocket boosters to fight the lunar gravity. Because the moon lacks an atmosphere, parachutes are useless. Every second of the descent required a precise burn of fuel to slow the falling craft. At just 100 meters above the surface, the probe did something remarkable. It hovered in total silence. Using high-tech cameras and laser sensors, it scanned the treacherous landscape below, searching for a safe haven amidst a sea of jagged boulders and ancient impact craters. One wrong move would mean a billion-dollar disaster. Finally, the craft identified a flat patch of gray dust and touched down softly in the von Karman crater. Moments later, the first close-up images of the moon's far side ever captured by humanity began to flicker across screens at mission control in Beijing. It was a moment of pure triumph that even the administrator of NASA called an impressive accomplishment. But as the dust settled, the real work was just beginning. Out of the shadows emerged U-2-2, the Jade Rabbit, a small rover weighing 140 kilograms with a mission to explore where no one had dared to go. The rover, named U-2 or Jade Rabbit, began its lonely trek across the untouched lunar plains. Though it stands only about 1 meter tall and weighs 140 kilograms, it carries the weight of a nation's scientific ambitions. Outfitted with panoramic cameras and ground-penetrating radar, the rover was built to peel back the layers of the moon's history. It moved with agonizing precision, traveling at a maximum speed of 200 miles per hour as it scanned the gray horizon. In early 2022, the mission took a turn toward the extraordinary. While rolling through the dust, U-22's cameras caught the glint of two translucent glass spheres resting on the surface. These tiny beads, roughly 15 to 25 millimeters in diameter, were about the size of marbles. While Apollo astronauts had previously returned with lunar glass, those samples were dark, opaque, and solid. These new spheres were different. They were clear, glistening like small pearls against the barren, desolate landscape. Geologists were stunned by the find. These glass globules are the product of immense violence, formed when meteorites slam into the moon and superheat silicon-rich minerals. The molten rock is thrown into the vacuum of space, where it rapidly cools and solidifies into glass. Beyond their beauty, these translucent spheres suggest that the moon contains the raw materials needed to manufacture high-quality glass locally. This discovery whispers of a future where astronauts could build windows and lenses using the very soil beneath their boots. While the glistening glass spheres captured the world's imagination, the most profound secrets were hidden at a level invisible to the human eye. In 2021, a team of Chinese researchers began an exhaustive analysis of the soil samples brought back by the Chang'e 5 mission. What they uncovered within that lunar dust was nothing short of a scientific revolution, the first confirmed presence of natural multiple-layer graphene on the moon. To the average person, this might sound like a technical footnote, but to the scientific community, it was a revelation that challenged everything we thought we knew about our celestial companion. Graphene is often called a wonder material. It is a form of carbon consisting of a single layer of atoms arranged in a honeycomb lattice, so thin it is essentially two-dimensional. Yet it is incredibly strong and conducts electricity better than copper. Its discovery on Earth was so significant that it earned the Nobel Prize in Physics in 2010. Finding it naturally occurring on the moon, buried in the dark soil of the Oceanus Procellarum, was a shock that rippled through the halls of astronomy. The researchers used a suite of high-powered tools, including scanning electron microscopy and Raman spectroscopy, to confirm the find. They didn't just find a few stray atoms, they found individual flakes of graphene, ranging from 2 to 7 layers thick. In some instances, the graphene had even formed complex shell structures that enclosed a core of minerals. This was not a product of simple layering. It was evidence of a bottom-up synthesis process, a sign that the moon's surface was once a site of intense, complex chemical reactions. For decades, the prevailing consensus among scientists was that the moon was carbon-depleted. This belief was a cornerstone of the giant impact hypothesis, the theory that the moon formed 4.5 billion years ago when a Mars-sized object named Theia collided with the young Earth. The sheer heat of that cataclysmic event should have vaporized volatile elements like carbon, leaving behind a barren, carbon-poor rock. But the discovery of graphene, alongside observations of carbon ion fluxes emanating from the surface, tells a different story. It suggests that carbon is indigenous to the moon, forcing us to rethink the very moment of our moon's birth. But the moon had even more to say. In 2024, as the Chang'e 6 mission ventured to the far side, it landed in the Apollo Basin to collect fresh samples from the oldest impact site in the lunar record. When those samples returned to Earth and were placed under the microscope, scientists discovered something even rarer than graphene single-walled carbon nanotubes. These are cylindrical structures made of rolled-up graphene sheets, prized for being incredibly lightweight, strong, and thermally conductive. Before this moment, carbon nanotubes were thought to be almost exclusively artificial, requiring precise laboratory conditions to synthesize. Finding them in nature is an extreme rarity, even on Earth. Yet there they were, shaped by the harsh environment of the lunar far side. Researchers believe these nanotubes were forged through a combination of ancient volcanic activity, micrometeorite impacts, and the relentless bombardment of the solar wind. The presence of iron in the soil likely acted as a catalyst, helping transform carbon atoms into these sophisticated structures under the pressure and heat of cosmic collisions. This discovery does more than just add another material to the lunar catalog. It proves that the moon is not a dead, unchanging world. It is a world with a rich, active history where volcanic eruptions and solar interactions have spent billions of years crafting complex materials. It confirms that carbon is far more abundant than we ever dared to imagine. We are beginning to see the moon not as a lifeless satellite, but as a dynamic archive of the early solar system, holding the raw ingredients that could one day fuel human civilization among the stars. If we can find graphene and nanotubes in the dust, what other secrets are waiting just beneath the next layer of soil? While the discovery of rare minerals and advanced carbon structures tells us what the moon is made of today, perhaps the most intriguing discovery from the far side has nothing to do with carbon at all. It has to do with the very moment the moon was born, a story of celestial violence that occurred approximately 4.5 billion years ago. Scientists believe that in the chaotic early days of our solar system, a Mars-sized object slammed into the young Earth. This ancient wanderer has been named Theia, after the mythical Greek Titan, who was the mother of Selene, the goddess of the moon. The collision was nothing short of catastrophic. The sheer energy of the impact turned both Theia and the proto-Earth into glowing spheres of molten lava. In this hellish forge, most of Theia's iron core sank deep into the heart of the Earth, becoming part of our planet's own core. However, a significant portion of the mantle material from both bodies was blasted into orbit, creating a massive ring of debris that circled the wounded Earth. Over millions of years, this debris cooled and coalesced, eventually pulling itself together into the silver orb we see in the sky tonight. This narrative, known as a giant impact hypothesis, is the favorite explanation among astronomers for how our moon came to be. The evidence for this theory is compelling. The moon's orbit follows a similar orientation to the rotation of the Earth, and our combined Earth-Moon system contains an unusually high amount of angular momentum compared to other planets in our neighborhood. Furthermore, the stable isotope ratios found in lunar rocks are nearly identical to those on Earth, suggesting a deep, common origin. But this is where the story takes a turn into a profound mystery that has puzzled researchers for decades. If the moon formed primarily from the remains of Theia, as most scientific models suggest, then it should logically have a different chemical signature than Earth. In the vastness of the early solar system, different regions were composed of slightly different materials. If Theia had traveled from a distant part of the solar system, its DNA, its oxygen, titanium, and iron isotopes should look unique. Yet they don't. The moon's iron isotopes are essentially identical to those of the Earth, a fact that simply does not make sense if Theia was a total stranger. In November 2025, a team of researchers led by Tiho Hopp from the Max Planck Institute for Solar System Research published a groundbreaking study that finally began to solve this riddle. They analyzed 15 terrestrial rocks and 6 lunar samples brought back by the historic Apollo missions with a level of precision that had never been achieved before. Their results confirmed the impossible Earth and the moon are indistinguishable in their iron isotopic composition. To find the answer, the team used complex mass balance calculations to model every possible collision scenario, testing various sizes and compositions for both Theia and the early Earth. Their conclusion was striking. The most convincing scenario is that Earth and Theia were not strangers at all, but close neighbors. Most of the building blocks for both planets likely originated in the same region of the inner solar system. Theia probably formed closer to the Sun than Earth, rather than in the distant outer reaches of space, as some theories once suggested. This realization changes how we understand the early history of our cosmic home. It suggests that the massive planetary collisions of the past weren't just random, chaotic events involving bodies from vastly different regions. Instead, they were collisions between neighbors' objects that grew up in the same environment, born from the same cloud of cosmic dust and gas. Yet, if they were neighbors, we are forced to ask, why did they collide? What force caused Theia to leave its stable path and crash into the Earth? One possibility is that Theia actually formed at a Lagrange point in Earth's own orbit, a stable pocket of space where gravitational forces balance out, but stability has its limits. Once Theia grew large enough, the gravity from other passing objects could have destabilized its position, sending it on a slow-motion collision course with our planet. We may never know the exact sequence of events for certain, but we do know that this one collision changed the course of history for every living thing on Earth. It gave our planet its moon, which provides the gravity needed to pull our tides. It tilted the axis of the Earth, creating the cycle of seasons that allows life to thrive. It sped up the rotation of our planet and may have created the very conditions necessary for life to emerge from the primordial soup. The moon isn't just a rock in the sky, it is a piece of ourselves, a twin born from fire and violence. And as China continues to explore the South Pole-Aitken Basin, one of the oldest impact structures on the moon, they are essentially digging through the archives of our own birth by dating the ancient rocks in this basin, which formed over 4 billion years ago. We might finally narrow down the window of the heavy bombardment that once scarred the inner solar system. This record has been lost on Earth due to the constant shifting of tectonic plates and the erosion of wind and water. But on the geologically quiet moon, the evidence remains perfectly preserved. The moon is the only place left where we can truly see what was happening when life first appeared on Earth. The achievements of China's lunar program have not occurred in a vacuum. They have drawn the intense gaze of the entire international scientific community. Even at the height of geopolitical rivalries, the sheer technical brilliance of landing on the far side of the moon cannot be ignored. Former NASA Administrator Jim Bridenstine himself praised the Chang'e 4 mission as an impressive accomplishment, a sentiment echoed by scientists across the globe who recognized that humanity was finally stepping into uncharted territory. This recognition, however, exists alongside a complex web of political tension that has fundamentally reshaped how we explore the stars. In 2011, the United States Congress passed a significant law that effectively prohibited NASA from collaborating directly with China on space projects without explicit authorization, often referred to as the Wolf Amendment. This legislation was designed to protect national security and prevent the transfer of sensitive technology. While its intent was strategic, the practical result has been a slowing of direct scientific collaboration between the world's two most powerful spacefaring nations. Yet, rather than halting progress, these barriers have pushed China to forge a different path, one defined by a broad network of international partnerships that span the globe. China has responded to these restrictions by opening its missions to the world. The Chang'e 4 lander was not a solitary Chinese endeavor. It carried sophisticated scientific instruments developed by researchers in Germany, Sweden, and Saudi Arabia. The Kekiao relay satellite, the essential bridge for all far-side communications, included a Dutch radio astronomy experiment. This spirit of cooperation has continued as China invited scientists from every nation to apply for access to the lunar samples brought back by Chang'e 5. By sharing this data, they have turned the moon into a shared laboratory, proving that while borders may exist on Earth, the quest for knowledge is universal. To sustain this growing international presence, the infrastructure in lunar orbit must be constantly renewed. In March 2024, China launched a new relay satellite named Quiqiao 2. The original satellite had already exceeded its intended lifespan, and a more robust successor was needed to support the increasingly complex missions on the horizon. Quiqiao 2 is more than just a replacement. It features innovative designs and enhanced functionality that allow for more intricate scientific exploration and more reliable data transmission. It stands as a silent sentinel, ensuring that the far side of the moon never falls back into silence. This satellite is the foundation for a bold new roadmap of exploration. The next major milestone is Chang'e 7, which is scheduled to launch around 2026. While previous missions explored the vast plains and deep basins, Chang'e 7 will set its sights on the moon's south pole, an area of profound strategic and scientific value. This region is home to craters that exist in permanent shadow, places where the sun has not shone for billions of years. Scientists believe these cold traps may contain vast deposits of water ice, a resource that changes everything for the future of humanity in space. Water is not just for drinking or growing food in the vacuum of space. It is the ultimate fuel. By breaking water down into hydrogen and oxygen, future explorers can produce the propellant needed to launch rockets from the lunar surface toward Mars and beyond. If water ice is as abundant at the South Pole as early data suggests, it could make long-term human habitation on the Moon not only possible but sustainable. Following closely behind, the Chang'e 8 mission, planned for 2028, will begin testing the technologies needed to utilize these local resources. This concept, known as in situ resource utilization, involves using lunar soil and minerals to build structures and manufacture tools directly on the Moon. Together, these two missions will form the basic model of an international lunar research station. This is not just a plan for a temporary visit, it is a blueprint for a permanent presence. China has announced its goal to establish a sustained lunar base by 2029, a vision that is now being mirrored by other nations. NASA's Artemis program is working toward a similar objective, aiming to return humans to the lunar surface, with a focus on that same South Pole region. With the European Space Agency, Russia, Japan, and India all preparing their own lunar missions, the Moon is becoming the center of a new kind of space race. This era of exploration is different from the one that came before. In the mid-20th century, the goal was to plant a flag and leave a footprint. Today, the goal is to build infrastructure, establish research outposts, and prepare for a deeper journey into the solar system. We are searching for answers to the most fundamental questions of our existence. Where did the Moon come from? How did it form? And what secrets are still buried beneath the South Pole-Aitken Basin as we move toward a future where humans live and work on another world? The far side of the Moon remains the key to understanding our past and securing our future. As we stand on the precipice of a new era of lunar discovery, we must address the elephant in the room. Rumors have swirled across the internet, claiming that China cut the live feed during the Chang'e 4 landing because they saw something they didn't want the world to know. Some suggest the glass spheres are evidence of artificial structures, while others claim the carbon nanotubes are too complex to be natural. These rumors, though captivating, are simply not supported by the evidence. The landing was not broadcast live in a traditional sense, and many details were kept secret beforehand, which is standard practice for Chinese space missions. In reality, the data from these missions has been shared with the international scientific community. The images are publicly available, and researchers worldwide are currently analyzing the returned samples. There is no evidence of a cover-up. What China found on the far side of the Moon is exactly what they have reported, and it is more than enough to change our understanding of the cosmos. To truly grasp the significance of these findings, we must review the incredible narrative China has pieced together from the lunar far side. They discovered translucent glass spheres, formed by ancient meteor impacts, proving that the Moon's surface holds the raw materials for future human habitats. They confirmed the presence of natural graphene embedded in the soil, the first time this wonder material has been found in the wild on another world. They identified single-walled carbon nanotubes created through volcanic activity and solar wind interactions, demonstrating that the Moon is a site of complex chemical processes. They gathered samples from the oldest, deepest impact basin in our solar system, which likely contains material from the Moon's hidden mantle. These discoveries are expanding our knowledge of the Moon's history and its potential as a resource for the future. However, the most profound mystery remains buried deep beneath the South Pole-Aitken Basin, that massive concentration of dense material that is physically pulling the crater floor downward. While the leading theory suggests it is the metal core of an ancient asteroid, it remains just that, a theory. China has landed in this basin 3 times now, and while they have mapped the terrain and analyzed the soil, they have not yet announced a definitive conclusion regarding this anomaly. This does not suggest secrecy, but rather the reality of the scientific method. Data of this magnitude takes years to fully process. The anomaly is only one piece of a much larger puzzle regarding why the two sides of the Moon look so completely different. The near side is covered in dark plains of solidified lava called Maria, while the far side is rugged, heavily cratered, and possesses a much thicker crust. One theory suggests the South Pole-Aitken impact itself added so much heat to the moon's interior that it flooded the near side with magma. Another theory once proposed that a second, smaller moon may have slowly collided with the far side, adding a thick layer of rock. While mapping by the Grail mission has ruled out the second moon scenario, the true cause of this asymmetry remains one of the greatest mysteries in planetary science. Understanding these differences requires us to look deeper than the surface. We know the moon's crust is made of light-colored rock called anorthosite, while the mantle beneath consists of denser rocks rich in iron and magnesium. At the very center sits a small iron-nickel core, which accounts for less than 2% of the moon's total mass. By analyzing the rocks excavated from the mantle by ancient impacts, we can finally determine if the moon formed hot or cold, and whether it ever possessed a magnetic field. This is the fundamental reason why China, and now the rest of the world, continues to return to the South Pole-Aitken Basin. For most of human history, the moon was a subject of myths and legends, an unreachable light in the sky. Then, between 1969 and 1972, 12 humans walked on its surface, left footprints in the dust, and brought back a piece of another world. For over 4 decades, we did not return, but the moon was never forgotten. Robotic missions have continued to map its craters and analyze its soil, slowly peeling back its secrets piece by piece. From the discovery of water ice at the poles to the confirmation of indigenous carbon, our understanding is constantly being revised. Science does not claim to have all the answers. It provides us with the method to find them. Sometimes the data confirms our expectations, and sometimes it reveals something that forces us to rethink everything. The journey of exploration is not about finding exactly what you are looking for, but being ready for what you find. The feed did not cut. The discoveries are very real, and the mission to understand our closest neighbor is only just beginning. China is not finished with the far side, and they are no longer alone. The United States, Russia, India, and many others are planning their own missions in the coming years. The far side, once the most inaccessible place in our solar system, is about to become one of the most visited. With each new mission, we will drill deeper, map in higher resolution, and study the anomaly until the truth is revealed. We are preparing for the day when humans return to the moon to stay. Every time we think we understand the moon, it surprises us. And every answer only brings another question. The moon is waiting, and so is the future of humanity.